So here's a few problems to review for the upcoming SAT. It is an assignment just because we got to assignment and give you guys credit for doing the work. So let's take a look at the first problem here. I don't know why I disabled 4 up there, but anyway, number 1. Which of the following represents the statement, the sum, so it's going to be an addition of what? The squares of x and y. So the sum of these squares just looks like this. Here's the sum and here's the squares. Then comes the word is, that's an equal sign. The square root of what? We need to know what goes inside the difference of x and y. Well, the difference of x and y is just found by x minus y or y minus x, but right away we can see that we have an answer. And we're done. Problem number 2. If a equals -2, figure out the value of a plus a squared, yada, yada, yada. So what we're going to do is just put that -2 in for every a that we see. Notice how when we have parentheses, or when we have exponents like this, I'm using parentheses to indicate you have to take the -2 to whatever the exponent is. Okay, and we have to do this one. This is a no calculator problem. -2 times -2 is 4. Then I bring down that negative. And -2 cubed, when you have a negative times a negative times a negative, that's what the 3 means. You're going to get a negative answer. And then 2 times 2 is 4 times 2 is 8. So that's a negative of a -8. Here we're taking the -2 to the 4th power. And that means you'll have an even number of negatives multiplied together. And they'll all come out to a positive. So we just have to do 2 times 2 is 4, times 2 is 8, times 2 is 16. Then we got our minus sign. That's this guy right here. And then we got to take -2 to the 5th power. So it's to an odd. We'll have an odd number of negatives, so the answer will be negative. And 2 to the 5th is 32. So there's what we just have to add up. So I can do some of it as I go. Here's the double negatives. They'll turn into a single positive, and then we got double negatives again, which will turn into a single positive. Now we're just adding all this stuff up. I'm going to kind of add it in groups here. It's a 16, and so I get 58 for a solution. Easy enough. Okay, let's jump to problem number 3 here. This is a tough one because we haven't done much with negative exponents before, but we can see, and I'm not quite sure why this x is in here unless it's truly part of the problem. I treated it like it wasn't one. I think it's a typo. Anyway, so we're solving for this x up here. This is the actual problem. And what you need to know about negative exponents is they mean reciprocal. And so x to the negative m means give me the reciprocal of that x to the m. And so it's normally over 1 like this. Okay. So that's what it means. And so we can manipulate these equations pretty easy. Here's what I would do is rewrite it without the negative exponent right here. So that's 1 over 9 squared. Equals the right side, which is 1 over 3 to the x. Then I'm going to do a little bit of work on the right-hand side just to clean up any confusions we'll have later on. But this x here means raise the 1 to the x and the 3 to the x power. But 1 to the x power, 1 to any power, is just 1. So that right hand of the equation is really just 1 over 3 to the x power. Now I'm going to keep working on this left side. See how we got a 3 as a base over here? I want that 9 to be a 3, and so we cleverly rewrite the left-hand side, the whole side in red, to a 1 over, instead of 9, we write the 9 as a 3 squared. Now that 9, the 3 squared, still has the 2 on it, this 2 right there, that squared. And this right here is the power to a power rule. When you have something raised to an exponent raised to another exponent like this, you simply multiply the 2 exponents. So 2 times 2 And so this becomes 1 over 3 to the 4th. And see, now our equations, or in our equation, the left side looks just like the right side. Numerator is 1, 1, then the fraction bar, then the 3, then the 3. The exponent is 4, the exponent is x. So if these two things are equal, I can see this exponent, this x, has to be a 4 also. Then 1 over 3 to the 4th would equal 1 over 3 to the 4th, which is true. So x has to be a 4. That guy right there. Question 4. It says, in the equation above, if a and b are positive integers, and a over b is the simplest reduced form, figure out what a is. Well, on the left side here, that's just an addition problem. You're adding two fractions. So to add fractions, you have to have a common denominator. So the least common multiple, the way you find your common denominators, here's the multiples of 8. I could keep going, but I'm not. Here's the multiples of 10. 10, 20, just take 10 times 2 times 3 times 4. And see, as soon as you get that common multiple, that's your least common divisor, or least common denominator. Now, since we're going for 40 in the denominators, we have to multiply each one times a version of 1. 5 over 5 is 1, and 4 over 4 is 1. Then when we multiply, we get 5 over 40 plus 4 over 40. Now we can add those, and that's 9 over 40. And that has to equal a over b. Now, it did say a over b is in reduced form, and 9/40 is in reduced form. I can't simplify it. And therefore, by comparison, I can tell the a is 9 and the b is 40. So a is 9. Number 5. This is a calculator question. I'm not sure why you'd need one. If 7 times a number is 84, that just says if 7 times a number is 84. Whenever you have a number you don't know, call it x or n, some variable. So x is our number, and then they want to know what is 4 times our number. Well, use this equation to figure out what x is. Then use this to figure out what 4 times x is. Because now we know what x is, we can answer the question. Problem 6. Problem 6 is very similar to the last one. 3x equals 12. Find 24 over x. So 3x equals 12. Divide by 3 to get the x alone. X is 4. So now we know what x is. Let's substitute him in and figure out what 24 over x is. And it's 6. So we're going to choose 6 for an answer. Problem number 6. So there should be a problem 7. I'm not sure where that guy went. I'll check into that. Apparently I skipped problem number 7. Alright, well this one is labeled 8. You can see it right there. Which one of these represents a strong positive association? Strong just means, are they clustered tight together? And if they are, then that would indicate a tight relationship between x and y. If it's a loose relationship, they're just kind of scattered. X is some number, and you have no idea what y is, okay? X is about, 2 here, and it's there or there. When x is 3, it jumps to there. When x is 4, it's down here again. So this is going to kind of go all over the place. So that's not strong. There's no association at all. This is kind of a linear positive correlation, but see, it kind of curves a little bit here. This one is a strong correlation going up this way, but this is a negative slope, and we want positive. And so it's clearly D here. That has a positive slope. Everything's tight together, so it's a strong positive. Positive slope, positive association. There we go, problem number 9. Simple one. 9, it says, to solve this equation, you could just plug them in here and just guess, and not guess, check, but just check them. Like if this is 4 in there, square root of 4 plus 22 equals 38. There's no way that's true. Okay, because the square root of 4 is 2, and 2 plus 22 doesn't give you 38, and 16 doesn't work. Square root of 16 is 4. 4 plus 22 isn't 38. I don't know what the square root of 32 is, but I know the square root of 36 is 6, and 6 plus 22 doesn't work, and the square root of 32 is less than 6. It's 5 point something. So it's not going to work. So the only one that can possibly work is D here. Now, the way you actually solve this problem is just like with the square root method we use to solve quadratics. You isolate the square root. So there's the square root, now it's isolated. And then once you got it isolated, you unsquare root it. How do you unsquare root it? You square both sides. And 16 squared turns out to be 256, just like we thought it would be. Problem 10. If the number in the following sum, if each number was increased by t. So I'm adding t's here. I'm going to change it to x's so it doesn't look confusing. X's are t's. Let x equal t. Okay, so if I added a t to all these, my x's, the new sum would be 4.22. So there's the problem I'm trying to solve. 274 plus this extra 4x equals 4.22. And so I just have to solve this. I'll subtract the 2.74. 4x equals 8. I think that's 1.48. X goes into that 3.37 times. There we go. Solved it for t. X in my case. 13 is kind of a tricky one here. 4 to the x equals n, plus times n squared equals 4 to the x plus 1 times n. Well, the first thing I'm going to notice is these are multiplications. So this is a factor and a factor and a factor and a factor on each side. And they both have n's in them, so I'm going to divide out one of the n's. On the right side, it cancels. On this side, it just leaves me with n to the first power. Now, I can do that as long as n does not equal 0, and I'm guaranteed it doesn't because that's not a choice for n. And so now my equation is n to the x times n equals 4 to the x plus 1. And this 4 to the x plus 1, this is the same thing as this. Remember, when you have common bases, you add exponents. So 4 to the x times 4 to the 1 is 4 to the x plus 1. And therefore, I now know what this n has to be. It has to be a 4. And see how the left side matches the other side. So n must be a 4 to make those things equal. And finally, number 11 here, it says figure out what c is. And they tell you the f of negative 2 is 6. And what that means is when you put in a negative 2 for x, the function should equal 6. And so you can subtract 4 for c very quickly. Looks like c equals negative 2. And you are done.